In this recording, we're going to show you a shortcut for doing polynomial long division. It's called synthetic division. And it's actually pretty cool. If you're dividing a polynomial by a binomial, and the leading coefficient of the binomial, in other words, coefficient of x, is a 1, you can kind of shortcut this process of polynomial long division that we did above here. So I've got the same exact questions that we did for polynomial long division. We're going to get the same answers using a shortcut, synthetic division. Okay, so I'll walk you through it and then we'll compare what we did to the polynomial long division. Okay. You might have noticed we kept having to change in our polynomial long division, kept having to change the addition here into subtraction. So we have to subtract, we have to change the signs. And so wouldn't it be easier if the sign were just opposite to start? So that's what we're going to do. We're going to take this x minus 3 and just write 3. We're going to ignore the x and just write 3. Okay? It's going to go outside of this sort of long L shape. Now, you also might notice we didn't ever really do much with the x squared itself and the x and the constant. We really just were looking at the numbers in front, the coefficients. So let's just take the coefficients of this polynomial and write them out. So I'll write, this is considered to be 1x squared. I'll write 1. This is 2x. I'll write 2. This is negative 5. I'll write negative 5. Okay? So if you're tuned out, tune in, because this is the algorithm for synthetic division. First step, bring down. You just bring that 1 right down. Next, multiply. 3 times 1. Write that underneath. 3. Next, add. Because adding is so much easier than subtracting. Make fewer mistakes. 5. Okay. Now multiply. 3 times 5. Now add. Okay. So now we have to interpret this answer. 1, 5, 10. Let's look back up at the polynomial long division. Where do you see a 1, a 5, and a 10? Keep in mind, we know we're going to have a binomial answer. So we know that the first term is going to be something x. So there's your 1, there's your 5, there's your 10. Now we just interpret that answer. So we write that out in that form. Okay, so we'd say, okay, all this means is 1x plus 5 plus a remainder, which we're going to express 10 over the divisor x minus 3. Pretty cool, right? All right, let's walk through this second example. Okay, again, change the 10 to be its opposite. We've got 10. Sorry, negative 10 to be its opposite. And make this structure that we can do our synthetic long division in. Why don't you, synthetic division, I should say. Why don't you put in the numbers across the top using the coefficients? Okay, so hopefully you wrote 2, negative 23, and 17. Okay, I'll walk you through the steps one more time. First step, bring down. You just bring that 2 right down. Now it's just a sequence of multiplication and addition. 10 times 2, 20. Add, negative 23 plus 20. Multiply, 10 times negative 3. Add, 17 plus negative 30. Interpret the results. So we know when we're dividing something with a square, a quadratic, by a linear, we're going to get x, some amount of x's in our quotient. So we know that's a 2x minus 3. And then this is the remainder over the divisor x minus 10. Okay, so check out above. Exact same answers that we got, right? But in my opinion, easier. You might say, hey, you wrote this one as plus negative, this one you wrote as minus. It's the same, guys. Exactly the same. Okay, so let's have you do part C the best you can, and then play the recording when you're ready. Okay, so hopefully you cranked this out. You wrote negative 1. That's a key step. A key source of error is to write just a 1 here. But keep in mind, we are changing our subtraction to addition, so we change the sign of this. So now we just write out the coefficients. Bring down, multiply, add, multiply, add, multiply. Now each time I'm multiplying the bottom number by the -1. And then add. So then express the answer. So you express the answer and play the recording when you're ready. Okay, so I hope you recognize dividing a cube by a linear. That means this leading coefficient here is of an x squared. So it should be 3x squared minus 5x plus 7 minus 12 over the divisor x plus 1. Okay. Finally, this last example I wanted to include because it has a little bit of a curveball. You might realize it's written in standard form, but it's a cubic that does not have all the terms. There's a missing term, and we have to account for that. So we will, as before, put in our 3 to represent x minus 3. Now, we have to be very careful here. There's an x cubed, that's our first one, and it's minus 1. There's a square, it's 4. There are no x's. So I can't just put 9 here, because that's representing where the x's go, so I have to put a 0. And finally, we just have the constant 9. Okay? So, why don't you go through the process, play the recording when you're ready. Okay, so it's bring down, multiply. Should be a minus there. Add, multiply. Add, multiply. 3 times 3, 9. Add. Now I just need to express the answer. Play the recording when you've got it. Okay, so if you wrote -1 x squared, and if you're saying, how do I know if it's x squared or what is it? It's an x cubed divided by an x, so you know that the leading term is going to be -x squared. And you just put in the rest of the terms. If there happened to be a 0 here in the quotient, you just wouldn't write that particular term. Okay, now the 18, the last number, if it's not a 0, is the remainder. So we'll write 18 over x minus 3. Thanks for watching.